Hi, and welcome back to the final installment in Red Siege's Shellcode Obfuscation Techniques series. So, if you've been following along with this series, we've looked at a bunch of different techniques for obfuscating shellcode. We've looked at doing things like encrypting shellcode, using substitution ciphers, other ways of obfuscating shellcode by reversing their order, and things like that. So, we've looked at a bunch of different techniques. Some of them are more effective than others, and some of them have been, frankly, pretty bad. But we've learned some interesting things along the way. So, in this episode, we're not going to look at any new techniques, but I'm going to give you some ideas for further research and take a look at just what we learned throughout this process. We've learned that we do need to obfuscate our shellcode. 100% have to do that because otherwise we're going to get detected. And we've learned that some techniques are better than others. But the key takeaway here when you think about that is that some techniques are useful against some engines, while other techniques are useful against different engines. So what might work against Defender for Endpoint might not work against CrowdStrike. And what works for Sentinel-1 might not work for another type of EDR. So you have to have multiple tricks in your bag. That's why we've covered a bunch of different techniques here. There are other things you can do for obfuscation. Obviously, everything we've looked at has had the shellcode embedded in the test program. You could distribute your shellcode separately. You could have your loader reach out to a web page and grab something. You could have it distributed with the loader, but in a different file. You could encode your shellcode into a resource file. So it's part of the program, but doesn't appear in the same section of the code. So there are lots of different ways that you could separate that. And I would encourage you to take a look at different techniques and understand the signatures associated with each of those techniques. But let's take a look at the results of our testing we've done here. So this table just contains a list of the score sorted based on how those did. So if we were to sort this in a decreasing fashion, we can see obviously that no obfuscation was the worst, right? Like just raw shellcode got detected, and it got detected a lot. That's what we expect. Base 64 encoding wasn't a lot better. Reversing the string, not great. UUID was the same. Once we start getting in some types of encryption, we see some improvement. The two array method scored about the same. The Caesar cipher or ROT13 did better than AES for some reason. Encoding shellcode as RC4, or rather encrypting it as RC4 encryption, encoding them as IP addresses or MAC addresses worked better. And then jargon, jigsaw, Zor with multi-byte, key, and offsets did better. Although, we saw in the last video, this is now 4, where at the time of this writing, it was 2. So there are different techniques that work better than others. And I would encourage you to get comfortable with these. I would encourage you to take these ideas and figure out how you can adapt them and come up with different obfuscation routines. So, with that in mind, I want to take you on a little journey and we'll take a look at a few different options. So, this happened to be posted by John Steigerwalt of White Knight Labs. And what we have here is this idea of instead of applying a XOR, he applies a XOR and then a not operator and then increments that value by some amount. And then in the flip side, when you want to reconstruct your shellcode, you would decrement that value, apply the not, and then apply the XOR. So that's something that you could definitely take a look at and make use of in your own loader. I would definitely take a look at that. In a follow-up post, John actually provided some assembly code that you could use to do this. So this is a really interesting technique. Another interesting technique that you could check out would be doing the Morph AES project. Morph AES was a play on the word Morpheus, of course. Morph AES is something that works on 64-bit Intel hardware with AES NI encryption chipsets. That would be most modern hardware that you're going to find today. And Morph AES implements encryption and decryption using AES 256 encryption, but it also introduces the concept of polymorphism by randomizing the constants in the program, applies logic changes and things like that. So it does have some polymorphic capabilities. It's an old repo, but I'm sure that if you played around with it and dusted it off, you would find some good use out of it. And the last piece is this concept of steganography. If you're not familiar with steganography, steganography is encoding data in images by altering either the alpha channel or the least significant bit of a color channel. And you can turn those bits on and off to encode data in there without significantly degrading the quality of the image. So that's something I would encourage you to take a look at. Take a look at some steganography libraries. There are ransomware actors out there that are using steganography. If you wanted to use it, you would encode your data into an image and then either distribute that image with your loader or have your loader go out and grab it. Thanks again for joining us on this series. I'm Mike Saunders, Principal Consultant with Red Siege. I hope you learned something and got something that you can take away and use as part of being an offensive operator. Thank you. Have a good day.